So let's continue today by looking at mechanism of current flow. You know that it is possible that a lot of people wonder what actually leads to current flowing, because from the beginning we have said that current is the flow of charges. So what are these charges? These charges are positive or negative charges. An electron is a negative charge. Proton is a positive charge. So you have different ions in an electrolyte. They are also what? Charged particles. So when we say that current is a flow of charge, is it all flow of charge that leads to current? So for example, in a metal, the predominant charge carrier in a metal, they are the electrons. The predominant charge carrier in a metal, they are the what? Electrons. Now, if you have a wire like this, you have electrons in the wire moving, but does the movement of those electrons produce current? No, because if you switch off a circuit, for example in this room I have wires. If I switch off the circuit that is going to a particular lamp here, there are still electrons in the wire and the electrons are moving, but the current is not on. The reason why, although the electrons in the wires are moving and there is no current flowing through that circuit, is simply because such movement of the electron does not produce current. So if you have a conductor that is connected to in a circuit and the switch is opened, the electrons in the wires or in the conductors are moving randomly. The electrons in the wires are moving randomly. So if you have a conductor that is connected to a circuit and the circuit is switched off, the electrons in the conductor are moving randomly. But when the circuit is closed, this end of the conductor is now at the positive polarity, and this end of the conductor is now at the negative polarity. It is the applied voltage that now makes this end positive and this end what? Negative. So electrons then drift from negative to positive. The current flows from positive to what? Negative. It is the drifting of the electrons in a straight line that produces current. It is not just motion of electrons. I repeat that. So if the circuit is switched off, there are no potential difference applied across the conductor. So the electrons in the conductor will be moving randomly. But when the circuit is closed, one end of the conductor becomes positive, the opposite end becomes what? Negative. And that forces the electron to drift in a straight line from negative to what? Positive. So current then flows from positive to what? Negative. Therefore, it is the drifting of electrons in a straight line that produces current. That drift, that velocity of drift is what is referred to as the drift velocity or the velocity of drift. So note that it is when a potential difference is applied to a conductor that makes one end positive, the other end negative, so that the electron drifts in a what? In a straight line. It is the drifting of the electrons in a straight line from the negative to the positive, because the electrons are negatively charged. It is the drifting of the electrons from negative to positive that causes current to then flow from positive to what? Negative. So that is the drift of the electrons in a straight line. Otherwise, the electrons in the conductor will just be moving randomly until the potential difference is applied across the world, the conductor. So let us look at equations here. So let us say we have a cylindrical conductor like this. The quantity of charge in that conductor is given as Ne, where this N is the number of charge and E represents the what? Elementary charge. The charge per unit volume, will be given as what? Ne over what? Over V. So I can call this one equation 1 today, because we have written this equation before. The number of charge per unit volume, This represents number of charge per unit volume. Per unit volume is known as number density of charge. Is known as number density of charge, and it is represented with this letter slanting n. So I can then replace n over v here. So I have q over v is equal to number density multiplied by the elementary charge. Is that okay? So that the unit on both sides is still charge per, the unit on both sides is still coulombs per meter cube. Is that okay? So both sides still have the same word units. Is that okay? Both sides still have the same word units. So according to what I've said there, that this n there is the number of charge per unit volume. So the unit on this side, on the right hand side of the equation, is still coulombs per unit, coulombs per meter cube. Now if you cross multiply this, so I can call this one equation 2. Note that this slanting n is different from this n. This n in the previous equation is the number of charge, but this slanting n is the number of charge per unit volume. So if you cross multiply, I'm going to have q is equal to what? NEV. This v represents volume. So recall that volume is simply cross-sectional area of the wire multiplied by its length. So you have the cross-sectional area of the wire, then you have the length of the wire. Is that okay? So I can substitute for this in this equation. Then write q to be equal to what? NE1AL. What is charge? Charge is simply current multiplied by time. Q is equal to IT. So IT is equal to what? NEAL. If I divide through by T, I'm going to have I, which is current, becomes what? NEAL over T. Is that clear? So question. What is L over T? But L over T represents what? V. This V is what is called the drift velocity. So I represent that one with small v, but the V here is capital V. So the current becomes what? NEAV. Equation 3. This V here is what is referred to as the drift velocity. So let me write it here. Current in terms of drift velocity is NEAV. Know that. That's equation 3. I, of course, you know is current. Current in amperes. N here, the slanting n is the number density of charge. Number density of charge, which is basically measured in per meter cube. Unit is per meter cube. Because number is not a physical quantity, it doesn't have unit. So the unit of number density of charge is per meter cube. E is the elementary charge. Elementary charge, which has a value of 1.6 times 10 to the power minus 19 coulombs. Elementary charge is the charge of an electron or the charge of a proton. Because the electron or the proton, they are the smallest charge that can exist independently. Then A is the cross-sectional area of wire. Cross-sectional area measured in meter cube. Is that okay? Then V, of course, is what we are talking about, the drift velocity, which is measured in meters per second. Okay? So that is just a simple way to derive the equation for current in terms of drift velocity. We started from here, Q is equal to N. You divide both sides by V. Charge per unit volume becomes N over V. This number of charge per unit volume is what is replaced with slanting N, which is known as the number density of charge. So we have Q over V becomes number density of charge multiplied by E. If you cross multiply, Q becomes number density of charge times E times V. So V is simply cross-sectional area multiplied by length. So Q becomes NEAL. If you divide both sides by T, L over T becomes what? V. So I becomes NEAV, where V is the drift velocity. And on this side of the board, I've written what all of them represent. So very quickly, we take a question.